All right, this video is for Calculus 1. It's differentiation in class practice number 23. But I want you to know that these two that I'm going to do are actually numbered 32 and 33 on this lab right here, which is the Inverse Functions Intros Derivative Lab. So I've asked you to do these, and 32 and 33 are kind of tricky, so I wanted to do them with you. So that's why I did it in our in-class practice. So go ahead and follow through with me. And then when you go to do those in your lab, try doing them on your own. And the first one is the inverse trig derivative of tangent. So if you see the word arctan, which I told everybody in class is the same and seeing it in this way as well. So this one is inverse tan is the same as arctan. And I know the derivative of this, okay, so is going to be 1 over 1 plus u squared times u prime. And a lot of times you'll see people putting the derivative right on top of that. So on top of, not the derivative, but the u prime right on top of that fraction. So that's the derivative we're going to use. Okay, so the first thing I'm going to do is I always tell people to kind of call this u if you want to, even though there's u's in it. So I'm going to do t prime of u is going to be 1 over 1 plus u squared, which is this whole fraction squared, times u prime. Now, u prime is the quotient rule. So my f is going to be the u, and g is going to be the 1 plus u. So f is u, f prime is 1 because that's our variable. G is 1 plus u, g prime is 1. So when I multiply this by the quotient rule, I have f prime g, so I have 1 plus u minus f g prime, so minus u, all over g squared. Okay, so calculus is done, folks. Now we're looking at simplifying this and make this look decent. First thing I notice is 1 plus u minus u. This is thanks for playing. That's a 0. And the other thing I want to show you is if I square a fraction, you're really squaring the top and the bottom. So we're going to rewrite that. So I'll show you this. T prime of u is going to be 1 over 1 plus u squared over 1 plus u squared times 1 over 1 plus u squared. Okay, it's looking a little bit better. Now, this is a complex fraction here, and we don't want a complex fraction. So I'm going to multiply every term by the common denominator, which is going to be 1 plus u squared. So I'm going to multiply everything by the common denominator. Okay, so now when I do that, t prime of u is going to be 1 plus u squared over 1 plus u squared, because u squared times 1, and then these will cancel, thanks for playing, plus u squared times 1 over 1 plus u squared. Now, when I get it like this, you're like, oh, cool, I have two fractions that I'm multiplying, and these I can cancel. They divide to make a 1. So I end up with, and then this I can actually, this should be 1 plus, I put the squared on the inside. It should be on the outside. So I'm thankful I caught that. So this is 1 plus u squared. So what I did now is I actually kind of multiplied this out. When I do, I get 1 plus 2u plus u squared, all right? And this right here, all right, is a u squared. So that's what I did. I wrote it too fast. So now when I do this, I got t prime of u equals 1 over, and then I'm adding these two u squared. So I have 2u squared plus 2u plus 1. And that is the derivative. So it makes it kind of nice. So let's kind of recap what I did. Is I actually took this and put it in our arctan derivative form. So it goes in here, multiplied by the u prime, which is the quotient rule. Saw that those canceled. Saw that I have a complex fraction here when I split up the squared. So I did that to it, simplified this right over here. Notice that I can cancel or divide to make 1, the 1 plus u squared, and then I just combined everything down here. So it makes it look a little nicer, and that would be the derivative. Okay, the next one is kind of fun. I love doing this one. There's a lot of ways to do this, and I think the answer key kind of mixed them up. So let me explain to you what you're going to do here. I already have a natural log here, okay? Soon as it's already natural logged, I can use my log rules. And that's what I'm going to do. I'm going to actually do this simpler by using log rules. And there's 3 log rules that we know about. And one of the first ones is you can always bring down the exponent down front. So I'm just rewriting this, and I'm going to bring that down front. Or, like someone told me, can I split this up and write it like this? So either way will work. You'll end up the same way. Okay, so by splitting that up and raising them both to the 4th, and I forgot the natural log here, you can actually the natural log is already there. Then I know I can split this up with subtraction and then bring it down. So this is going to be the same as the natural log of 1 minus cosine of t to the 4th, okay, minus the natural log, because I'm going to pull it apart with subtraction because there's division in there, 1 plus the cosine of t to the 4th. And then I'm going to bring the 4 down front. So I end up actually getting this function, 4 natural log of 1 minus cosine of t minus 4 natural log of 1 plus the cosine of t. Okay, so this right here is the exact same thing as this. Notice there's no derivative. All I did was use log rules to expand it so I can use the derivative. So I know that if y equals the natural log of u, y prime is 1 over u times u prime. It's one of the easiest and the nicest derivatives. So by me getting it all set like this, I can use that derivative now to do it. So here we go. Now I'm whoa, I didn't mean to do that. I hit something there. Let's come back. Okay, so what I'm going to do here is now I'm starting a prime of t. This is right here is the first time I started doing the derivative. Okay, so ready? 4 times, this is my u, 1 over u times u prime, and the derivative of 1 is 0. The derivative of cosine is negative sine, but it's negative, so it's going to be a positive times the sine of t, okay, minus 4 times, this is my u, 1 over u times, made that kind of long, times u prime, and the derivative of cosine is negative sine of t, okay? I know a lot of you would combine that right off the bat, but I'm just taking my time to show you how to do the derivative. Now I've got a prime of t is going to be 4 sine of t in the numerator all over 1 minus cosine t. And this turns positive because I have a negative sign and a negative 4, so plus 4 sine t all over 1, whoops, this is a 1 plus cosine, 1 plus cosine of t. Okay, so again, that is the derivative, and there's nothing wrong with that, but I'm going to continue on with some more algebra so that we can have one term, all right? So the first thing I'm going to do right here is common denominators, okay? So we're going to do common denominators right here, which I know is going to be both of these. So a prime of t is going to equal, ready? The denominator is 1 minus cosine t times 1 plus cosine t. And when I want to see what I'm missing here, I'm missing the 1 plus cosine t, so I'm going to multiply this whole fraction by 1 plus cosine t. So I have 4 sine t times 1 plus cosine t because that's what I'm lacking. Here I'm missing the 1 minus cosine t. So I have plus 4 sine t times 1 minus cosine t. Okay, so far so good. You're thinking, how does this make it better? Well, ready? This is a term here, and this is a term here. I can recognize by looking at that I can pull out 4 sine t or factor it out. So I'm going to So I have 4 sine t. I'm going to factor that out. When I do, I have a 1 plus cosine t left of my first term, plus a 1 minus cosine t left of my second term, all over. And I'm going to multiply this out because a lot of times people go, you said leave it factored, but there's going to be a reason for this. So I'm going to write this as multiplied out. And if you'll notice, this is the difference of 2 perfect squares, and that's how we'd write it. So that's what it comes out to be. And then I see, oh, thanks for playing. The cosine t's will cancel out. Okay, so now I have a prime of t is 4 sine t, and I'm multiplying it by a 2 because that's what's left in that fraction, or in that parentheses, all over 1 minus cosine squared t. So now I have 8 sine t all over 1 minus cosine squared t. Now, one of the reasons that I did this, so here is another little thing, we are going to use an identity right here for the denominator. And I know that sine squared theta plus cosine squared theta equals 1. So if I move the cosine squared over there, this whole thing ends up being sine squared. So I have a prime of t equals 8 sine t all over sine squared t, because that's what 1 minus cosine squared is using this identity. And then I go, oh, yay, I can cancel that out and this out. So I end up with 8 over sine t, which is a beautiful way to write that. So I just want to kind of go through this one more time with you. I used log rules to expand this. I first raised both of these fractions to the 4th power. Because it's logged, I know it's dividing. I'm going to pull it apart with subtraction. Then I use another log rule to bring down the 4. Remember, this is not the power rule, so I'm just bringing it down. So I got to here where I've actually come up with the exact same thing that we started with, but it's been expanded. From there, right here, I start doing the derivative, and I did 1 over u times u prime. So the 4 is there, 1 over u times u prime, 1 over u times u prime. I come up with this with 2 fractions, and then we did common denominators to make this one term, and went through and did that part, factored out the 4 sine t, saw that the cosine t's canceled, and I had a 2 here, and then I multiplied that, so I came up with here, realized that this is an identity, and then I rewrote that as sine squared t, and it simplified down to 8 sine t. So I hope that this helped you. So make sure that you try doing this on your own. And if you need more help, you can watch this video. So I hope it helped.